Hi guys, welcome back to my YouTube channel. In this video we are going to see the explanation of Hooke's law and few questions with the answers about Hooke's law. Let's start. So the definition for Hooke's law is Hooke's law states that extension is directly proportional to the deforming force or load or weight. Here the deforming force means a force which makes an extension on any object. Extension means increase in length. Here you can see a spring without any load. So this is the original length or initial length. So once a load is added, the spring extends from its original length. So how to find the extension of the spring, that is how much the spring extended from its original length is measured length minus the original length will give us the extension. So here is the example. For 1 Newton force, it makes 10 mm extension on this spring. Again, when we add one more 1 Newton, that is 2 Newton, the extension is 20 mm. So that is directly proportional. For 1 Newton, 10 mm. For 2 Newton, 20 mm. So it obeys Hooke's law. So here is the extension load graph. When we deal with past paper questions, you have to double check which graph is given. Sometimes they may give load and length graph, rarely, but mostly they give extension load graph. How do we know extension load graph means? Here, without any load, there is no extension. So it starts with 0, 0, 0 load, 0 extension. But in some graphs, they will give here length. Length means even though no load, there will be some length. So that graph doesn't start with 0 for length load graph. For extension load graph, it must go through origin. So please keep it in mind. So from where to where it obey Hooke's law means it is directly proportional, means if 1 Newton load 10 mm extension, 2 Newton load 20, 3 Newton load 30. So this is directly proportional. So up to x the graph is straight, that is the line is straight. So it obey Hooke's law up to x. So x is the limit of proportionality. You must be thorough about this point. X is the limit of proportionality. That means the extension is proportional to the load. So what does this point E says is E is the elastic limit. Up to E, the spring behaves elastically and returns to its original length when the load is removed. Beyond E, the spring is left permanently stretched. So when we remove this 2 Newton load, if this spring goes back to its original length, means that is the elastic limit. If the spring stays with some extension, means like this, after removing this load, then it is beyond its elastic limit. So these two things are very important. Please do remember, up to x it obey Hooke's law. So if it obey Hooke's law, x is the limit of proportionality. Up to this it obey. Beyond that it is the elastic limit. Beyond the elastic limit, the spring is left permanently stretched. So it has a formula that spring constant, that is load equals spring constant times extension. In symbols, F equal K times X. But in the coming questions, we are not mostly going to use this equation. Most of the questions we will solve by using the graph. So please do remember, extension load graph means it must starts with origin, because if no load, no extension. Let's start solving few past paper questions and answers. When the question starts, you can pause the video and you can try the answer by yourself. Then you can play and check your answer. Let's start. Let's try this first question. A spring obeys Hooke's law. A spring obeys Hooke's law. Which graph is obtained by plotting the extension of the spring against the load applied? The answer is A, because as we discussed earlier, it is an extension load graph which obeys Hooke's law, so it starts with origin and the line must be straight. Try the second question. A student adds weights to an elastic cord. He measures the length of the cord for each weight. He then plots a graph from the results as shown. Which length has he plotted on the vertical axis? So to do this question, you can see here the line is straight and it starts with origin 0, 0, and here it is the weight or load. So which quantity has taken in this vertical axis? As it starts from 0, 0 and the line obey Hooke's law, we all know that here it must be extension. So as we discussed earlier, what is extension means measured length minus original length. So the answer is C, measured length minus original length. Try this third question. Objects with different masses are hung on a spring. The diagram shows how much the spring stretches. The extension of the spring is directly proportional to the mass hung on it. So they have given clearly the extension is directly proportional. It means it obeys Hooke's law. So what is the mass of object M? In various methods you could find the mass with simple logic. Initially 0 mass 10 centimeter. Once 100 gram is added, it extends 10 centimeter, because this 20 is the total length of the spring. So 20 minus 10 is 10. So 100 gram makes 10 centimeter extension on this spring. Now you keep this as an initial length 20 centimeter with 100 gram. Then again we are adding some mass. Its total length is 30. So 30 minus 20 is 10 centimeter. As we know, 100 gram is making 10 centimeter extension. So here it is 30 centimeter is the total length. So 30 minus 10 is 20. So we know 10 centimeter extension is created by 100 gram mass. So here it is 20 centimeter extension from the initial. So it will be 200 gram. So the answer is C, it is 200 gram. In simple way, for 20 centimeter 100 gram, 30 centimeter it will be 200 gram. Try this fourth question. The diagram shows a steel spring and a graph of its length against the load applied to it. Here you can see the graph is length against load, not extension. So what is the extension of the spring when a load of 20 Newton is applied to it? So here you can see it is not an extension load graph because it is not from the origin, it is length load graph. So initially the length of the spring here, it is 5 centimeter is the initial length. Once 20 Newton force or load is added, the total length of the spring is 8 centimeter. So what is the extension means? As we discussed earlier, the measured length or final length minus the initial length, that is 8 minus 5. So 3 centimeter is the extension of the spring. Try this last question. The extension load graph for a spring is shown. The unstretched length of the spring is 17.0 centimeter. When an object is hung from the spring, the length of the spring is 19.2 centimeter. So what is the weight of the object? So here they have asked the weight of the object. So here they have asked to find the weight, that is load. So load is there in the graph. So how to find the load means they have given the length of the spring after some load. Initially the length of the spring is 17.0 centimeter. So 19.2 minus 17 is 2.2 centimeter. So for 2.2 centimeter, from the graph we can find the corresponding force here. So that is this 3.0 Newton. Hope you understand. So I hope this video would help you a lot in solving Hooke's law questions. Thank you so much for watching.